Okay, so the bulk of chapter 4, most of chapter 4 starts right now. Um, it's not like split into two sections. It's split into multiple sections. We don't take that too seriously, but if I kind of look ahead, the way that I look at it, it's kind of split into two major sections. So the first half, which is, approximately 10 pages, is what I have written on the board here. And it is the most important part. It's kind of the easier part, but also most important. And then the second part, which is also important, I don't mean to say it's not, but the second part, which is approximately another 10 pages, 10 or 12, is more theories and concepts that go beyond this into surplus and things like that. So it's a lot more than this, but the first 10 pages I've kind of summed up here. Now, you know how I kind of like to make these basic points, and I'm going to say over and over again, chapter 3 and 4, but this is basically what we're moving into now after marginal utility. And it kind of also shows how it's obviously just a regurgitation of chapter 3. We're in 4. But I really shouldn't mention chapter 3 because it doesn't really help us. But remember, chapter 3, we had the isoquant and the isocost. And then over and over again, I said that for the most part, chapter 4 just kind of re-outlines chapter 3, the first 10 pages, the first half. That's absolutely true. But what we're going to have is this straight line is something called the budget line. So in the last chapter, it was called the ISO cost. It is, I do forget the terminology sometimes. It's a different concept and it's called something completely different. In chapter 4 that we're in now, it's called the budget line. That's what it's called. So we have a budget line, which is always linear. And I'm talking about this a little bit. I just kind of sharing my thoughts. I always get a little bit ahead of myself, but we're going to go through this more thoroughly as we derive it. But the next 10 pages kind of derives and does other stuff. There's a lot of stuff to be said here, a lot of stuff. This is not all of it. I wouldn't even say it sums up all of it, but these are the basics beyond, besides the 4 different ways of writing a slope. Yeah, so that right there is we'll talk about where that gets derived, but it is a straight line of y equals mx plus b. Usually up here, I didn't write that, but this is a quantity 2 as a function of quantity 1. That's usually what we have going on here. And then a Cobb-Douglas, as always, what is this? So in chapter 3, it was called a isoquant. In chapter 4 that we're in now, it's called an indifference curve. It specifically is U. It's U, it's U, it's U. That's what it is. And it's a graph of our utility. And there's a few, there's always theory that goes in there, but with most homework problems, we always care about this one and only one point where I always have to take a moment to say it, uh, where the budget line, yeah, where the budget line, yeah, where that intersects the indifference curve. Yeah, exactly the same as chapter 3, but different terminology. And what do we know about the very obviously where they intersect? At the point where they intersect, they have the exact same slope, and all the homework problems are about that one concept. Anyway, so that's that doesn't sum it up, but it does pretty good. And now we just kind of start. And most of the 10 pages derives this very thing. So we'll do all of this better. We do some example problems, and there's obviously a bunch of smaller, also important concepts that I haven't talked about. So we just do all of this in order of the book. Okay, so marginal utility is just a derivative. Yeah. So remember, utility was in the previous couple of videos, introduction, but utility is our preference, usually as a function of quantity or price. So as always, whenever we use the term marginal, we're talking about a derivative. Since our utility function u has 2 variables, q1 and q2, we're interested in 2 partial derivatives. Yeah. The marginal utility of good 1, mu1, and the marginal utility of good 2, mu2. They have it right there, but obviously just you have the utility. Yeah. So I always kind of get a little bit ahead of myself because I can't always remember, but I talk about u as a function of quantity, and I talked about u as a function of income or price. This one comes mostly in later chapters. I said that one's more important, but it's in many chapters. Right now, we're typically talking about u as a function of quantity. So I didn't make that clear in the previous 1 or 2 videos. Yeah. So what is U? U is always, for the rest of this chapter, going to be our utility is a function of quantity 1 and quantity 2. So obviously these would be the partial derivatives, derivative with respect to quantity 1, derivative with respect to quantity 2. Yeah, we can read all this here is fine, but derivative with respect to quantity 1 is change that when Q2 is constant and vice versa for the other one. So they describe all of that right here. So for a Cobb-Douglas utility function, there it is, figure 4.1a. Okay, so they always do kind of the basic graph of whether we need it or not. But they give us a function as an example, and if you take the derivative with respect to Q1, that's going to be MU1, marginal utility 1, you get that. So no need to dwell. It is a slope, so it is the instantaneous change, which in real life is impossible. So we have to know our basic calculus without explaining it. But what does that mean? It means if we're only, the smallest thing we can do is a change of one quantity. So it's the approximate change in our utility up and down, up or down, with the increase of 1 unit. That's what that's always going to be. Infinitely small unit, which is impossible. So it's an approximation. It is an approximation there. For an increase in 1 unit, which is what the marginal is always supposed to represent. And what happens with the y increase or decrease, but increases or decreases by how much with 1 increment increase in x, or in this case q. Okay. So anyways, it's always the same here. So this is not a derivative. On the right is the derivative, but we still don't graph the 3D. What they're doing there is you could do u. I just don't want to skip anything. We could do u as a function of q1. What is that? That's q2 equals a constant. Yeah. Or we could do u as a function of q2. That's a q1 equals a constant. Yeah. So either graph is the exact same curve. I mean, not the exact same. The the scaling of it, the axes there change. In fact, I should say just the y changes, but the shape of both are the same. So it doesn't matter if it's u as a function of q1 or q2. This is u as a function of q1. So they always do this. There's not a lot of meaning here. They do this in every chapter, but we always graph the derivative. So if we take the partial of u with respect to q1, as you increase the quantity, our utility is always increasing. The y value is always increasing. The derivative, of course, graphs the slope. The slope here, yeah, the slope is going to be the y value, which is actually the way that I wrote that. It's way the heck down here. But, they're going to do, I'll say it when they get there. I always forget the diminishing. We won't talk about it yet. But they're just talking about, obviously, as the quantity increases, our utility increases, but they're saying the rate of increase is decreasing. Yeah. So they just want us to always show that thing there. Yeah, all review, all very easy. Okay, so this is kind of what I was talking about before. So we talked about all this. Now we talk about it a little bit better, I think, in the next video. Yeah.